I have to admit, this question has me a little conflicted. On the one hand, this is the new SAT, and I'm a big fan of solving systems of equations using the Desmos calculator, right? We don't need to solve this thing in any algebraic way. Let's just put this thing into the calculator, see where these two lines and parabolas intersect, and then that's going to give us one of our answers. So we could do that. However, my old SAT brain really sees this just in a much simpler way. This is a classic plug points into equations. And I obviously have two equations and 4 points, but the right answer is going to be the point that works in both equations. And if these points were complicated, right, if they had big numbers or just annoying fractions, anything like that, I would absolutely go to the calculator here. But I'm really tempted because there's that 0, and the second equation is especially easy for me to think about, 6x minus 12. I can do any arithmetic with that in my head very easily. So what I would do is just kind of go through each point and plug it in. Now mentally I'd be able to do this without having to write it down, but I'm going to show you, right, what it actually means is we're saying that the x coordinate is 0, and I want to get a y coordinate of whatever in the point. So for choice A, I'm saying we would have 2 is equal to 6 times 0 minus 12. Well, that's not true. 6 times 0 is 0. 0 minus 12 is negative 12, so not 2. So I know that that's wrong. I don't need to bother checking it in the other equation. If I do the same thing for choice B, 2 is equal to 6 times negative 4 minus 12. So 6 times negative 4 is negative 24. Negative 24 minus 12 is negative 36. We're way off from 2, so that also doesn't work. Here we would have 0 is equal to 6 times 2 minus 12. Again, with very little mental math, I know that that's true. 6 times 2 is 12. 12 minus 12 is 0, so that seems good. I would need to check choice D in this same line before I pick C. So I would do that, and I would say, okay, negative 4 is equal to 6 times 2 minus 12. Well, again, 6 times 2 is 12, so 12 minus 12 is 0, not negative 4. So I haven't bothered to check this point in any of the equations here, or in any of the top equations. I didn't bother to check any of these points in the top equation because only one of them even worked in the bottom equation. That was not guaranteed. And even if I had multiple points here that worked, it's still not that the top equation is very complicated. So I could plug in whatever's left over in that equation and test it out that same way. And in this case, I feel really confident doing that just because the arithmetic is so easy. But like, if you don't see those numbers as easily as I do, that's all the more reason to go to the calculator. So let me just show you what that would look like. Let me clear out this old question. In this case, we're going to enter both of our equations. So y is equal to, parentheses, x minus 2 times x plus 4. Just make sure you're entering it right. These buttons are very small. I get very nervous. Y is equal to 6x minus 12. X minus 12, and then we're just looking for the point of intersection, and luckily Desmos kind of like highlights it for us. You can see it right here, this little gray, and they just tell us that it's 2, 0, and that was the point I ended up picking. So that might be much easier. You know, I think maybe like I dragged it out when I showed you, but I don't know. To me, it would have been a simple choice, you know, or it would have been the same choice. It would not have really saved me time to do that. And I guess I'm more nervous about entering the equations wrong than I am about doing the arithmetic wrong, but that's because I feel good about arithmetic. If you do not, then don't do the arithmetic. Then don't do plug points into equations here. Instead, plug equations into your calculator, and it just tells you. So most systems of equations, point of intersection, you are going to use the calculator. This to me felt like a little bit of an exception for me and a little bit of a nostalgia moment for me because I love the plug points into equation strategy so much.